Again, it's not a threat, by the way. Okay, so this one, and we've seen one like this already. Remember this one? We're looking for this at the 16 and 8. Pretty much ignore right now. Pretty much ignore your exponents. Okay, we're just looking at a comparison of 16 and 8. Now the problem with 16 is if I split it up with the base 8, then I get another base which is 2. That's no good. Okay, so that means I'm going to continue splitting up 8 because this 8 can split up between 4 and 2, and now we kind of see what the common base is here with the 2's. Because 8 split, yeah, this, I'll go to this one. 4 splits up into 2 and 2, and this one's done. Okay, so 8 really is 2 to the power of 3. And this one, that's 4 times 2 again, and then 4 is 2 times 2. Okay, so 16 is really 2 to the power of 4. Now that takes some finagling, but I've now forced the bases to be the same, while if I tried to make the bases 8s, that was not going to work. Now, something I probably should have mentioned before is usually you're trying to make the smaller of the two numbers the base. 2 bases. If you look at the 2 bases, you usually want the smaller base to be your main base. But again, the problem with this one was when we split the 16 up into a base 8, we got a different base or another factor, which was not an 8. Okay. So let's go and rewrite these then. Let's go back to our original problem. We got the 16, but now I have it as 2 to the power of 4. And yeah, I'll put this in parentheses. And I've got the 8 base, which again, we changed that one also, is 2 to the power of 3. That's a 3. And these are all, these both have their own exponents, right? 3x to the power of 2 and also x plus 2. And these should be equal. Now, the bases do match. And technically, if you know your exponent rules, you could get rid of the bases right now. I'm gonna continue with them as is, just in case we don't notice that. Okay, so that means I'm gonna distribute the 4 into this. You could put parentheses around there if you'd like. But then you'd have 4 times 3x's, which is 12x's, and 4 times positive 2, which is positive 8. Of course, we still got the base 2. And then on the right side, we're keeping the base the same, but I'm distributing the 3 into, again, what would be parentheses there. 3 times x would be 3x, and 3 times 2 is positive 6. Okay, so these two are equal. But now I don't really have to worry about any more operations within the exponents. So I'm going to just move to get rid of those bases. So I got just the exponents. 12x plus 8 should equal the other exponent, 3x plus 6. Well, this just becomes an equation that we need to solve. So let's go ahead and get moving with this. I'm going to put x on the left, numbers on the right. That's another way to look at it. Hopefully it's still okay. But in any case, I don't want that plus 8 there. I'm gonna zero that out by subtracting 8. And I do it on both sides. I'll do it just to save some space here. I'll subtract 3x as well simultaneously. These values zero, these terms zero out, but 12x's minus 3x's is 9x's. And 6 minus 8 is negative 2. And the last thing for us is I'll just divide both sides by 9, which shows that x should be negative 2/9. And that should work, okay? But I'm gonna go to my calculator and just check. So by replacing the x's in the original equation with this fraction, again, the values are pretty ugly, 40.3174736, but they match. That's all we need.